So how's your algebra? You on point? Can you reduce things? You got your conjugates on lock? You know how to add fractions? You know how to reduce? You know what I mean? This is where we need to be solid. This is going to be kind of the tricks to this. And hopefully those tactics work. Sometimes we have to actually just know what's going on with functions in order to answer it. Like limits as they tend towards infinity and negative infinity. Those can be the tricky ones. But with these, we're going to look at, these are going to be, I don't want to say it's straightforward, but we don't have any of those where we need to know what the graphs actually look like. It's just pure algebra. So let's tackle this first one. So we got our function here. Here we go. There's our function sitting inside our f of x. And we want to know what the heck is going to happen to that function. Remember, every time you have a function, it creates a graph and stuff like that. So what happens to your y values is that x value gets really freaking close to 5 from both sides. Now, you don't have to fully have that concept down, except for the fact that, you know what, if you take that 5 and you plug it into that denominator, you're going to get 0 minus 0, which is going to create a 0, and we have problems. Okay, so you get that 0 down there, that's, we know we got problems. Now, if you get a 0 up top, that's typically telling you do a little bit of freaking algebra, and the problem's going to pop out. So if we were to plug in that up top, that'd be, 5 to the negative first minus 5 to the negative. I'm pretty sure that's going to be 0, and you got 0 over 0. So it's not really problems, it's just do more work. Okay? 0 over 0. I will be a total asshole about this. If I ever see in your writing that you divide by 0 and you, without any sort of work, you just state it equals 0, I will take all of your points. I probably threaten you in other videos too, but I just really want to make sure we know so it doesn't come out of the blue. It's a big concept in this class, and saying that dividing by 0 just makes something equal 0. Oh, that's like the cardinal sin in this class. So just know, means do more work, we get 0 over 0. All right, enough of me preaching. Gosh darn it, let's get to the dang problem, huh? Let's get rid of all this stuff. Let's get rid of that. You know that 0 over 0. I've already said it a few times. So let's do some freaking algebra, dude. So I'm just going to manipulate this for right now. So I need to just rewrite the limit. You got to write the limit each time until you plug in your a value. Our a value being 5 this time. But let's write this. I don't need that. I don't need that. Let's write this. And the only thing I'm going to change is just the numerator. Just our numerator. That x to the negative first power. Let's rewrite that as 1 over x. And that 5 to the negative first power, that's 1 over 5. It's really common for students to want to say, oh, this just goes down here. And that's not true. That's not how it works. So you just need to rewrite it in that way, and then we can go. So now what we have is, there's our numerator, essentially, and there's our denominator. How we change it, maybe we can put this all over 1, so you can kind of see how the fraction works. You don't need the 1s there, but we need to now clean this up. What's your choice? What's your choice? How do you want to do this? Do you want to add these two together? That's no big deal. Or do you just want a fraction bust? And I think I want a fraction bust by using the least common denominator, which is going to be that x and that 5. 5x. But I can't just multiply by 5x. I need to do it to top and bottom. Cool. So let's rewrite our next step. And oh gosh, how am I doing it? I'm writing the limit again. I did it. Somehow pulled it off. Okay, now let's deal with the denominator first. So there's an implied parenthesis. Now, I don't want to create and expand shit out. That's terrible. Factored is dope. We're just hoping there's a trick that's going on up top. So we're going to rewrite this in. I'm going to put the 5x out front, and then we'll put this x minus 5 here. So it just took that times that. Just put it down to the denominator. No biggie. Now let's just bring this in to both those pieces. So we got our x over 5. So now instead of writing 1, we'll write in 5x. And there it is. All right, we multiplied by 1. Those fancy frickin' ones we gotta have on lock. So as we clean this up, we see that our x's are gonna go away here, and our 5s are gonna go away right there. So let's rewrite and see what we got. So the limit is x is tending towards 5 of 5 minus, right? Because the x's went away. Minus the 5s went away, just leaving you with the x over 5x times x minus 5. Woo! We're there. Do you see it? Do you see it? Don't feel bad if you don't. We're going to get good at seeing these things. So this is going to be like you're a step away. You're about done. You can like just cancel stuff out and be all right. And what's going on is we got this 5 minus x and we got this x minus 5. The 5 minus x over x minus 5, that equals -1. Reason being, let's take 5 minus x just over to the side and just say if you change the sign and just ripped out a negative from this, what would happen? What's the opposite of 5? -5, right? What's the opposite of negative x? That's positive x. So this is actually just equal to, let me turn this around, negative x minus 5. So let's change our problem. We got to get good with this. It's a requirement of the course that you understand. And you have this, or you're going to miss little points here. Sine there's a, I don't want to say bad words. There we go. Let's just cross those x minus 5s out. We go through, oh shoot, wrong color. Oh, so now we have the limit as x is tending towards 5 up. That canceled out up top, so that just leaves us with our -1. We got our 5x times that's x minus 5. And gosh darn it, there we go. We can now plug in. We don't have, oh, why did I write x minus 5? That thing goes away. Why did you let me write that? All right, isn't that what we just canceled out? Wasn't this the reason why we couldn't plug in 5? Absolutely. So why don't we just finish this problem off, and we're going to plug it in and say that this is the limit. Oh, we don't have to write limit anymore because now that the domain issue is gone, we're just going to take that 5, plug it in for x, and say that this is -1 over 5 times 5, or -1 over 25. Ooh. What's that, about 4 pennies of a dollar? Negative. Okay. -1 over 25. Let's see our next one. Holding on, making it through. This can be a very discouraging class at the beginning because you're required to know everything from algebra. Everything. And that's, for some of us, that's just not a reality. So just hang in there. Let's get it. Oh, I like these types of problems. These are fun. These are fun. Okay. I'm going to save you a little bit of time of going through all this and just let you know if you're to plug into the denominator and you're going to get a 0. Like if I was tackling this problem, didn't know what was going on, I'd just plug into that denominator and see that there's a 0, and automatically I'm like, okay, I don't even need to mess around with the top. I know I need to start doing frickin' algebra. But if you were to continue going on, you find out it's a 0 over 0 case, which means do more work, which means let's get that algebra going. So we need to come up with, and here it is, the fancy one. We keep creating these magical frickin' ones that come out of frickin' nowhere, they seem like sometimes. I know it felt like that for me. But here's our one. It's going to be big, and what it is it's our frickin' conjugate. It's just our conjugate because we have this square root minus a number. This square root minus something else. And screw it, even if it's a number. We should write it in its conjugate and try and multiply by that. So the conjugate would be the first thingy, right? And then we put a plus sign, and that would be the second one. What we've now done is created an a minus b times an a plus b. This gets rid of roots really well. It gets rid of this really well, because that just equals a squared minus b squared. So if we're saying that our a was equal to the square root of x squared plus 7, and our b is just equal to 4. So for our formula, our a minus b times our a plus b, we're going to get our a squared minus b squared. And this is a trick. You don't have to show your step. You can always just jump right down to it. So since we hit it with our conjugate, we're going to say, all right, so what's a squared? We just remove the root, and that leaves us with x squared plus 7. Now we put in a minus because we have, there's our a squared, and then minus our b squared. Since our b is equal to 4, what's 4 squared? 16. Oh, but if we're going to do it to the top, we sure as heck got to do it to the bottom, or we're going to be changing the problem, and that's not okay. Now, whatever is not the conjugate, please do not put that crap together. We like things factored. We like shit factored as much as possible. So we're going to want to keep that as our x squared minus 3x times, and we'll leave that, sorry about my, everything kind of screwing up right now. My machine is very warm. I want to keep that stuff separated. So let's look, because I'm going to cheat right now. You better be paying attention. 7 minus 4 squared. 7 minus 16 is -9. So what we have up top is x squared minus 9. I cheated, so if you missed that, just go back. And that's what it is. Can't we factor? That's really what we want to keep doing. Just factor, 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 and factor. Because we still have our frickin' domain issue. We know it's still there. It has to still be there. So, do you mind? Let's just factor this thing up real quick. Let's factor the top. Let's factor the bottom. Let's see what's going on. So there's our difference of squares again. It's like I'm beating this dead horse. There's an x squared minus 3 squared. An x squared minus 3 squared? Well, shit howdy. This has got to be x plus 3 times x minus 3, right? That difference of squares. Well, let's go factor our denominator. Look at that, x squared and that minus 3. So let's take an x out. That's going to leave us with x minus 3. And then we got that nonsense at the end. But look at there. It's like this game is just cooked up for things to just gone. And that x minus 3 in the denominator, this has been the frickin' domain issue. This is what's been making our life suck. Now that that thing's gone, let's get it. We write it out. What are we left with? X plus 3 up top. Now we just got an x. Square root of x squared plus 7. Now we got that plus 4. Let's plug it in. We're ready. We're just going to take that 3, put it in everywhere you see an x, and that's going to be our solution. So we get 3 plus 3 up top. 3, and then we got the square root of 3 squared plus 7 plus 4. What's that going to be? What do we get? That's going to be a 6 over a 3. And what's that going to be? So what is that? 9 plus 7 is 16. The square root of 16 is 4. 4 plus 4 is 8. Those go away, give you a 2. What do we get? About 1/4 out of this bad boy? I think a 1/4 might be the answer to this one. So be ready for stuff like that. That's a legit problem, huh? That thing's legit. All right. All right. Here we be. Here we be. Quiz 1A. Congratulations. You get a quiz. So quiz 1A, well, this is going to be due the first Saturday. The first Saturday. Just look on your schedule. I'm not going to put a date down because I reuse these things. Saturday, 11:59 p.m. I'll get this. I'll get it. And the week 1. Okay. 2 problems. Turn it in as a PDF. Just like you did with your little like welcome quiz. Remember that thing? Oh, have you finished that yet? It's a lot, isn't it? Turn in the welcome quiz. Same way. All right. Same way. Okay. Same way you turn in your welcome quiz. Same way you're going to turn this shit in. And look at the schedule. It'll be there. So, here we go. The first problem. Should be able to go get that. Not that big of a deal. Second problem. You're probably going to have to watch the videos that come after. Okay. I don't think I've given enough information yet for that one to really work out. But there you go. First quiz. Yeehaw! See, they're not so long. Just a couple problems. Just keep you engaged. Listen to my stupid voice. Just put me at 2 speed. Turn me into a freaking chipmunk and just make sure to get this stuff done. So, good luck.